Okay, today we're talking about square root functions and graphing them, also graphing inequalities. So update your table of contents in your title page. And there's your parent function. So copy that down. And then the transformations. And the transformations are all similar to what we've had in the past. Okay, so let's start by graphing this one. Now our transformations said that a minus 2 means that it moves to the right 2. So we first of all have to know what our parent function is. So our parent function is related to x squared. So x squared, if we were to make a table, if we put 1 in there, we get out 1. If we put 2 in there, we get out 4. If we put 3 in there, we'd get 9. And 4, we would get 16. Since square root undoes a square, it's considered its inverse, meaning that the x and y can switch place, or they just switch places. So 1, 2, 3, 4 now goes in your y column, and 4, 9, 16 goes in your x column. So to graph this, we start by finding our starting point, which we said is to the right 2. So on your graph paper, go to the right 2. And from there, we go over 1, up 1. Now we go over 4, up 2. And then we would go over 9, up 3. Kind of running out of room though, so this will have to be good enough. That is what our square root function looks like when we have an x minus 2 underneath the square root. Okay, it also says to identify the domain and range. So domain is when we have a vertical line running across our x-axis. When is this going to be touching the function? It's touching it here up until this point. Over here it's not touching it at all. So it touches it when x is greater than or equal to 2. So the domain is x is greater or equal to 2. The range goes the other way. So the range is when I'm running this way. It's touching here. It's not touching down here. Now up here, even though it looks like they are going parallel, the square root function does keep increasing. And so it will eventually reach it, even though it looks like they're going to become parallel. They don't. So we know that it doesn't matter where that line is, even if it's way up here, it will eventually reach it. It's just going to take a long time to get there. So the range is from this point and above, anything greater than or equal to 0. So we write it as range is when y is greater than or equal to 0. Okay, let's try another function. Okay, this has some more information in it. So sketch your x and y axis and write down this equation. So negative 4 moves to the right 4. Remember, it's opposite of what we think it should be. This moves it up 2. And that number, the 3, affects the slope. So we start by figuring out our starting point. So we go to the right 4 and up 2 and make a dot. Now we need to set up our table. So remember we said 1, 2, 3 goes down our y column, and then we square it for the x's. It's 1, 4, 9. But now this time we have a 3 for a slope. So that means we have to take our y values times 3. So this 1 now becomes a 3, this 2 becomes a 6, and this 3 becomes a 9. So this is how we plot our points. From our starting point, we go over 1, up 3. Again, from our starting point, we go over 4, up 6. And then again, I can't do the 9. So we just do these points and then draw an arrow to continue it on. So there's our graph. Now let's describe the domain and the range. So the domain, vertical line running along my x-axis. So it's not touching until this point, and then it's touching over here. So it touches when x is greater than 4, greater than or equal to 4. The range then is touching up here. It is not touching down here. So the range is when y is greater than or equal to 2. Now if you notice, if you look back at the last problem, you'll start noticing a pattern here. This 4 is related to that 4 right there. This 2 is related to that 2 right there. So the domain is the opposite of the number inside the square root. The range is the same as the number that's being added at the end, the constant term. Okay, let's take a look at another one. Again, write down the equation with the x and y axis. Plus 5 is going to move it to the left 5. Minus 6 is going to move this down 6. So that's where we're going to start. Go to the left 5 and down 6. Okay, now the negative, remember that's like a -1, is how our y values are going to change. So we start off with this basic table again. 1, 2, 3 down our y's. 1, 4, 9 down our x's. And this time we multiply our y's by -1. So this becomes -1, -2, -3. So this time we're going to go over 1, down 1. Over 4, down 2. Over 9, down 3. So we have reflected the function because we have a negative out in front. So let's do the domain and range again. Domain is a vertical line. So it does not touch over here. It touches from this point and greater. So we say that the domain is when x is greater than or equal to -5. Again, it's related to that inside number. The range is below that point. So the range is when y is less than or equal to -6. And again, it is related to that point up there. Now, all of the problems that we've worked with have had no number directly in front of the a. So let's look at a problem that has a number in front of a, or I'm sorry, in front of x, and figure out how we're going to work with this. So take a second to read through this problem. You can hit pause. Okay, so we have to look at this, and we can't have that 2 in front of the a. We have to have it outside of the square root. So we can split apart the square root like this. Just like when we do like the square root of 20, we can break that apart as square root of 4, square root of 5, and then we'd keep working with it. But we can split apart a square root like this. Now the square root of 2 is actually our slope. So this function is not being moved to the left or right at all, or up or down. So our function starts at 0, 0. So on your graph paper, put a dot at 0, 0. But now we need to make our table and change the slope. So 1, 2, 3 down the y's. 1, 4, 9 down the x's. And this time we're going to multiply it by the square root of 2. Now since we're graphing this, we're going to want this as a decimal answer. So if we take 1 times the square root of 2, we get about 1.4. 2 times the square root of 2, we get about 2.8. And 3 ends up being 4.2 approximately. So now we plot those points. We go over 1, up 1.4. Over 4, up 2.8. Over 9, up 4.2. And that's our graph. Now it does not ask for the domain and range, so we don't need to do that for this problem. But now let's use our graph to analyze it. It says the velocity is 4 meters. It wants to know what the centripetal acceleration is. So if we go back to this graph and estimate it from the graph, we would look at our velocity, which was y, acceleration was x, and we want to know at 4. So if we trace over 4, according to our graph, if velocity is 4, acceleration, let's put a squiggly line, is about 8. Okay, so let's try another problem that has a value in front of the variable. So this one has a 3 there, and we can't have that. So we have to factor out a number in front. Now we also have an inequality, which we can work with at the same time. So let's start by factoring out the 3. And we have an x plus, remember when you're factoring, you're dividing it out. So this would become 5/3. Because if I were to distribute that back in, I would get just 5. Now I split that apart. That's the square root of 3. The square root of x plus 5/3. All right, if I'm ready to graph this then, this part right here tells me to go to the left 5/3. So 5/3 is 1 2/3. So I go over a block and then another 2/3. Now I need to set up my table to know where to go from there. So x, y, 1, 2, 3 down the y column, 1, 4, 9 down the x column. And this time I need to multiply it by square root of 3. So 1 becomes 1.7, 2 becomes 3.5 if I round that appropriately, and 3 becomes 5.2. So now to plot these points, I go over 1, up 1.7. Now this will not be hitting any of the crossbars. Now go over 4, and up 3.5, and over 9, up 5.2. And there's our graph. Oh, unfortunately I drew a solid line. I shouldn't have. Let me get rid of that. I should have gone 9 and 5.2. Now, because of this inequality here, I need to have a dotted line. Remember, if we would have had a line underneath it, I would have done a solid line. And now it's greater than, so I need to shade above. For square root functions, what you do is you draw a line straight up from your starting point, and then you just shade above the graph. Okay, all right, there's our lesson on square roots. You can go ahead and write down your questions and summaries, and let me know if you have any questions when you get to class.